the rest of his life, he was to commemorate that October day as his anniversary day, the birthday of his great dream. By the 1920s, after years of studying physics and engineering, he was experimenting with liquid fuel rockets. In order to build a rocket capable of reaching high altitudes, Goddard had to create the principles of an entirely new technology. He invented the basic components that propel, stabilize, and guide the modern rocket. It was painstaking and difficult work, but Goddard took the many setbacks in stride. He sifted the wreckage of each experiment for clues to guide the next. Constantly refining old techniques and inventing new ones, he gradually raised the rocket from a dangerous toy and set it on its way to becoming an interplanetary vehicle. Goddard died in 1945 before a rocket had ever left the planet Earth. Although Mars always remained his objective, Goddard knew that such a goal would be ridiculed. In public, he advocated only the more modest objective of flying to the moon. Those boyhood dreams of voyages to the moon and Mars, shared by Goddard with his contemporary, a Russian scientist named Konstantin Tsiolkovsky, were fulfilled only a few decades after their deaths. But, as it turned out, the first planet to be explored by rocket was the Earth. Now, imagine yourself a visitor from some other and quite alien planet. You approach the Earth with no preconceptions. Is the place inhabited? At what point can you decide? When we look at the whole Earth, there are no signs of life. We must examine it more closely. If there are intelligent beings, maybe they create engineering structures which can be seen at a resolution of a few kilometers. Yet, at this level of detail, even a great river valley seems utterly lifeless. There's no sign of life, intelligent or otherwise, in Washington, D.C., or Moscow, or Tokyo, or Peking. If there are intelligent beings on Earth, they have not much modified the landscape into regular geometrical patterns at kilometer resolution. But when we improve the resolution tenfold, when we begin to see detail as small as 100 meters across, the size of a football field, the situation changes. Many places on Earth seem suddenly to crystallize out, revealing an intricate pattern of straight lines, squares, rectangles, and circles. Canals, roads, circular irrigation patterns all suggest intelligent life with a passion for Euclidean geometry and territoriality. On this scale, intelligent life can be discerned in Boston and Washington and New York. At 10-meter resolution, we also discover that the Earthlings like to build up. At twilight or night, other things are visible. Oil well fires in the Persian Gulf, or the bright lights of large cities. And at meter resolution, we make out individual organisms, seals on ice floes, or people on skis. Intelligent life on Earth first reveals itself through the geometric regularity of its constructions. If Lowell's canal network really existed, the conclusion that intelligent beings inhabit that planet might also be compelling. But there is no canal network. Our unmanned spacecraft have examined Mars with 1,000 times more detail than any fleeting glimpse available through Percival Lowell's telescope. There is no question that his Martian canals were of intelligent origin. The only question was which side of the telescope the intelligence was on. Where we have strong emotions, we're liable to fool ourselves. Yet, even without the canals, the exploration of Mars evokes the kind of rapture that Columbus or Marco Polo must have felt. We see many impact craters, but we find no canals, none at all. There are fault lines in the surface and complex patterns of ridges and valleys, but they're all far too small and in the wrong places to be Lowell's canals, and they don't seem to be manufactured. There are many signs of water. Ancient river valleys wind their way among the craters. Nergal Valley, named after the Babylonian war god, is 1,000 kilometers long and 1 billion years old. There seems to have been a time when Mars was much warmer and wetter than it is today. I wonder if life ever arose in the muddy backwaters of these great river systems. The waters flowed at the same time that the great volcanoes of the Tharsis Plateau were made. Before the present continents of Earth were formed, it was a very lively epoch on Mars. Equally old is the Mariner Valley, a strange, vast, mist-filled chasm. If it were on Earth, it would stretch from New York to Los Angeles. Landslides and avalanches are slowly eroding its walls, which collapse to the floor of the valley. There, the winds remove the particles and create immense sand dune fields. Signs of high winds are all over Mars. Often craters have, trailing behind them, long streaks of brighter dark material blown out by the winds, natural weather vanes on the Martian surface. For the sand to be blown about in the thin Martian atmosphere, the winds have to be very fast, sometimes approaching half the speed of sound. But some of the patterns are so odd and intricate that we cannot be sure they're caused by wind-blown sand. And there are other strange markings. Furrowed ground, almost resembling a giant plowed field 1 billion years old. And one of the strangest features on Mars, the pyramids of Elysium, 10 times taller than the pyramids of Egypt. Perhaps they're only mountains sculpted by the fierce winds, but perhaps there's something else. How marvelous it would be to glide over the surface of Mars, to fly over Olympus Mons, the largest known volcano in the solar system. The surface area of Mars is exactly as large as the land area of the Earth. It will be a long time before this planet is thoroughly explored. The only canal of Percival Lowell that corresponds to anything real is Mariner Valley. 5,000 kilometers long, it's a little hard to miss even from Earth. The Grand Canyon of Arizona would fit into one of its minor tributaries. Someday, we will careen through the corridors of the Valley of the Mariners.